Welcome to The Explainer. Today, we are jumping into a topic that's literally all around us, pushing on us every single second. It's the secret behind everything from a super sharp knife to a giant construction vehicle. So yeah, let's dive into the fascinating world of pressure. So to kick things off, I've got a question for you. Think about a trampoline, right? Have you ever wondered why, when you stand on it, you sink way down, but if you lie down flat, you barely make a dent? What's the deal with that? Okay, so check this out. In both of these pictures, the person's weight, the force pulling them down, is exactly the same. So if the force hasn't changed, something else has got to be at play here to cause such different results. And that's the core puzzle we're going to solve today. And that brings us right to our first section, the pressure puzzle. Let's get to the bottom of what that something else really is. The secret, believe it or not, is actually pretty simple. It all comes down to how you focus that force. See, when you're standing, your entire weight is concentrated on the small area of your feet. But when you lie down, that very same force gets spread out over your whole body. So let's put a proper name and, some numbers to this idea of focused force. It's time to get into the core formula. In physics, we call this concept pressure. And the definition is right there on the screen. It's the amount of force that's acting on a specific unit of area. So it's not just about how hard you push, it's about how concentrated that push is. And here it is, the whole idea in one beautifully simple equation. P equals F over A. Pressure is just force divided by the area it's spread over. And we measure pressure in pascals, or pow. 1 pascal is just 1 newton of force over 1 square meter. So remember this, if you keep the force the same, but you make the area smaller, the pressure goes through the roof. And you see this principle in action every single day. Just look at this knife. A sharp knife has a really, really tiny surface area on its cutting edge, right? That means even a small push from your hand creates an enormous amount of pressure, letting it slice right through that carrot. A dull knife, it has a bigger area, so you have to push way harder to get the same result. Okay, so we know we can create huge pressure by focusing a force. But what's really amazing is that we can flip this principle around to do some incredible things. We can turn it into a force multiplier. Let's have a look at hydraulic systems. These systems use a liquid, which can't be squished or compressed, to transmit pressure and basically multiply force in a way that feels almost like a superpower. And this whole thing works because of something called Pascal's principle. It's a fancy name for a simple idea. If you apply pressure to a liquid in a sealed container, that pressure is transmitted equally to every single part of that liquid. It doesn't lose any strength. The pressure is the same everywhere. Now that should make you pause for a second. If the pressure is the same everywhere, how on earth can a small, gentle push on one end lift a massive car on the other? It seems impossible, right? Well, let's break it down. First, you apply a small force on a small piston. That creates pressure in the liquid. Now, thanks to Pascal, that exact same pressure is now pushing on the bottom of a much larger piston. And since we know force equals pressure times area, well, that same pressure acting on a much bigger area creates a much, much bigger output force. It's just a beautiful piece of physics. So how much bigger are we talking? Well, get this, a small input force of just 50 newtons can be multiplied to produce a whopping 5,000 newtons of output force. That is 100 times stronger, more than enough to lift a car. Now, pressure doesn't just happen when we're pushing on something from the outside. Liquids actually have weight, and that weight itself creates pressure. So let's look at the weight of a column. This picture is such a perfect way to see it. Just notice how the water shooting out of the bottom hole goes the furthest. Why is that? It's simple, really. There's more water sitting on top of it, pressing down. The deeper you go, the more weight is above you, and so the greater the pressure. And of course, there's a formula for that too. The pressure in a liquid is P equals H times rho times G, where H is just the height or depth of the liquid, rho is the density, basically how heavy the liquid is for its size, and G is the gravitational field strength. And what's wild is that the shape of the container doesn't matter at all, only the depth. And this formula is so important in the real world. It's the reason why deep-sea submarines need to be built like armored tanks to handle that immense pressure. It's why your ears pop when you dive to the bottom of a deep pool. And it's even the core principle behind a barometer, which measures the weight of our entire atmosphere by seeing how high that pressure can push a column of mercury. Okay, let's bring all these ideas together now. Time to map it all out in our final section, your world under pressure.
Now, this concept map might look a little complicated at first glance, but don't worry. It's just a great summary of everything we've talked about. Just follow the lines. See how our main idea, pressure, which is force per area, branches out? On one side, it leads to hydraulics, and on the other, we see how pressure in liquids depends on depth, which explains things like barometers. It's all connected.
So, here's the big takeaway. Pressure is so much more than just a formula you have to memorize. It's a fundamental tool that lets us understand, predict, and engineer the world around us, from designing a submarine to just making a simple kitchen knife work better. And that leaves us with one final thought. You now get the physics behind pressure. You know the code. So my question to you is, where else do you see it? Think about sports or nature or other kinds of technology. Keep your eyes open, because now that you know what you're looking for, you're going to start seeing it absolutely everywhere.